Right then, where are we? So we're going to carry on with some of the zero-to-quake-3 project where we try and rebuild a quake-free engine or game in a combination of Haskell and Vulkan. Let's just recap to where we've got so far. I believe the last stream we just finished off building a little FPS camera into this. And I think what we're going to look at today, oh, we also, we've got this nice module structure now. This is all starting to take shape. Did a lot of refactoring. I'm going to carry on today with a little bit more progress and see if we can implement a BSP loader, or at least start to lay the groundwork for that. I'm not sure we'll get it done. Oh, this isn't good. Our environment seems to have broken. It's a pleasant surprise. Has the linker stopped working? Oh, this could be, sorry, I think this is me. I was messing around with some stuff. Let's turn that off. There we go. Yeah, so I was curious after the stream what our core looked like, and I just enabled this dump core plugin, but it doesn't actually let me build anything. But it does give me core, which is kind of cool. So there we are. There. Go upside down. Oh, I don't know what I've done with my camera there. So we clearly need to add some clamping to that. There we go. Yeah, so we can move around here, which I think will put us in a good place. If we load a BSP, we can actually find it, see it, kind of stuff like that. So, let's get our to-do list in place. Let's just start doing that. So I think a good starting place here is just doing the basic file I/O, loading a BSP into some type of memory representation. So that's going to take a file path and give me back a BSP or something like that. So we haven't said what a BSP is or anything like that. You have to think about that. So, what is a BSP in terms of its physical layout? So there's this really nice page of these unofficial quake-free map specs, which describes in pretty good detail what is in a BSP file. And it's actually quite a nice file format, pretty easy to parse. Basically starts with 4 bytes of magic, which is the string IBSP, and the version identifier, which is always 0x2e for quake-free files, and then basically a kind of table of contents of offsets into the rest of the file. So you've got 17 of these dir entries, and a dir entry is just the byte offset and the length of bytes that we need to read for that entry in the directory. And as to what each directory entry means, they're laid out in this particular order. So for what we're interested in of loading a map, we don't care about entities, which are index 0, we don't care about texture information, don't care about plane information, nodes. We will care about the BSP tree leaves, because they correspond to kind of individual parts of a level that get rendered. And we're also going to be interested in leaf faces, So every leaf has multiple faces, and each face is, I think, a flat polygon. I'm pretty sure it's a flat polygon, which is basically a wall in that leaf. What else are we interested in? Leaf brushes are just for collision data. Models are, not going to worry about them. Brushes are referred to by leaf brushes, and brush sides are referred to for brushes. We don't care about them. We obviously need to know about vertexes, so bring that in. Mesh verts, I don't think we need to worry about that. Faces is referred to from leaf faces, I think. So basically you end up chasing a bunch of pointers. It's an exercise in indirection, I suppose. So to start with, maybe let's just start looking at dumping out this header. I'm going to bring in the byte stream module. Do I want to do it this way? We've got like a bunch of options, I guess. Like I could use a raw byte string and slice it up, or I could use something like megaparsec. But basically, I don't think we want to literally parse this into Haskell, because we're just gonna re-upload it straight to the GPU. We're not actually interested in the data that's inside this. So I think maybe a byte string is the right idea, and we can start to just slice this into kind of ranges. Yeah, let's carry on with this and see what we get. So read file BSP file path. And let's see, so we're expecting IBSP. Might as well check for this as a good sanity check. So what do I need to do there? Data byte string char8. Well, you could use like a state monad, I suppose, to do a basic parser. Options, plenty of options there. So drop and stuff are all 01. We've got constant time indexing into these things, so yeah. That works well with a state monad though. No, okay, I'm gonna, yeah. So what does that take? 4 bytes. Take one of my old quake-3 resources. So I'm not going to be able to distribute this in the Git repository, of course, but you can get Q3DM1. Just you just grab the quake-3 arena demo and unpack it, and you should find that. But that is the official first level of quake-3 arena, so we might as well use that one. This is probably going to be nice if we just work in GHCI. So good. So we've read the first 4 bytes and we've seen IBSP. So next we need to drop 4. Is that 4 bytes? That might actually be 1 byte. The version, yeah, it's just 1 byte, which is 0x2e. Cool, that's okay with that as well. And then after that, we have our dir entries. So these I do want to parse. Let's have a type for this. So what is a dir entry? It's an int offset and an int length, and these ints are 4 byte integers, little endian. So we have de, is that offset length? Yeah, offset. Okay, so int 32. Okay. That's data. Maybe split it would be not. I'll stick with this for now. Yeah, let's just get saying out. We can do the refactoring later. I'm thinking too far ahead here, I think. So dir entry. Take 4. A is a byte string. What am I talking about? I'm just conscious that we do seem to be writing basically a half-assed parser. So how do we turn 4 bytes into a single integer? We do it with byte string lexing. Pass and produce, possibly. No, that's not what I want really. So that's about like ASCII encoded numbers. That's not really what we're looking for. Probably a binary package. Which does suggest, yeah, we could just use a kind of proper parser like that. What's the endianness of this? I have a feeling it's the wrong endianness. Yeah. That gives us big endian bytes, which isn't really what we're looking for. Is there a way to get... No, doesn't really say. We'd have to write it manually, but that's fine. Yeah, so let's go ahead and just use the binary interface. So yeah, let's see what this gives us. The problem is this get doesn't let us know how many bytes something needs, and it has a fixed amount of bytes. We may make a different type class to represent that. Yeah, so I was suggesting there of using binary or serial. Sorry, I missed that. We seem to have come to the same conclusion that it's probably going to make more sense. Like, it is binary data at the end of the day. So data.binary.get. Yeah. Oops, what happened there? So let's see, how do we run one of these get things? They take a lazy byte string. Fine, we'll just change over to that. Char we probably don't need. So it doesn't have support for ASCII. What about serial? These are quite nice. But no, also doesn't do ASCII, but that's okay. We'll take this map. Yeah. So does this give me a way to just get a byte? I guess word 8 is that. We'll just return a list of dir entries for now, I think. So that's gonna get those, yeah, and I need a dependency on binary and a way to run that. Be nice if it was in a monad rather than calling error, but how are we looking on that? Happy enough. Right. Okay, so it's going to be so let's replicate number first. So was that 17 of these? Cool. That doesn't look right though. Negative offsets and stuff. What have we done wrong here? These are all looking definitely quite wrong. BSP, that's at 0x2e. Ah, but that was an int, so I only read 1 byte. So that should have been int first 2 I think. That looks correct to me. Well, these are looking like reasonable numbers anyway. No negative offsets. Okay. So BSP file can just contain all of those 17 things. We don't need them all at the moment though, so let's do BSP vertices first. Kind of want to really avoid having to introduce a list and stuff like that as well. Do you have any config uploads to GitHub like format? Yeah, I do actually. So just a little diversion there. Keeps open on the side while I keep typing. Just head to ocharles and then .charles. Oh, and there was a nice suggestion there of rather than using this guard, why not just do that? Which is kind of cool. That's nice. Oh, cheers! Somebody else has already dropped the link, and I messed that. So yeah, So I don't want to like. What might seem obvious is BSP vertices as a list of vertex, but then I'm actually having to allocate a ton of memory just to build this list structure up in Haskell. But we don't, like I've said before, we don't care about that because we're just going to blast it straight to the GPU anyway. So let's just go something more general, which is just going to be a vertex list. What that is going to be just a byte string, and maybe probably just the size. Well, I have the size actually, just from the length. Like, yeah, probably just that. Let's see if we can get by with that. And this is then just a case of taking these dir entries and slicing it out into here, and then we can just stick that memory straight onto the GPU, map it directly onto it. Let's bring the unofficial Quake-3 map specs in here as well then. I seem to recall there's some annoying padding in these as well, but we'll find that out later. So this is going to be entities, textures, planes, nodes, leafs, leaf bases. Or should I screw it, we'll just keep it like this. Leaf faces, leaf brushes, models, brushes, brush sides, vertexes, we do care about, verts, effects, faces, or line maps. roles is data. No, that didn't really work. So a BSP has what's going to be a little tricky though. Maybe I should have got the whole byte string straight away. Oh, but I don't think you can. Can you? So that I don't actually care about. Let's see if that works. Does that actually then pop it off though? Because basically the difficulty here is these offsets are offsets relative to the start of the file. So I need access to that like underlying byte string that I got originally to then index into it. I could of course like adjust my offsets based on how many bytes I've read so far. Oh, I suppose that's not too bad. I probably have access to that, don't I? Or maybe I should use a look ahead. Yeah, okay, let's do a look ahead. So this whole header can just go in here. Now I can that. That's a lazy byte string now. Yep. Someone mentions bytes read. Oh, to get the number of bytes read, yeah. But then, like I said, I kind of want to avoid having to do a load of arithmetic on these offsets. It's just another place for me to mess this up. So I think the look ahead is going to be the way to go about for this. Cool, so get BSP is now string BSP. Yeah, so I mean, there's not really anything interesting to look at there, because this is just a huge byte string. I guess what we can look at is BSP versus vertex. Just to make sure we got things correct. Fancy check. (61052). I don't know if that's correct or not. Yep, looks good to me. So that's what we had in our directory entry. So if we've got vertices, that's a start. We need to turn those into faces. Actually, this I think might be enough information to start doing some rendering. So a face has a huge amount of stuff, but we don't actually care about most of this for now. So we could use this to build our index buffer up, but I think we do have to parse this. Let me just think and recap. Because basically, if we go back to our rendering code at the moment, which I think is in here, we do vk cmd draw indexed, which takes the amount of indices we want to draw, and I think it's got an offset to the first index, or to the offset into that index buffer. Oh yeah, we also have to distinguish based on whether it's type 1 or type 2 and stuff. We're only going to worry about type 1 for now, which is polygon, so it does also support yeah, Bezier patches. You have to tessellate those yourself. Maybe we could do that with a geometry shader or tessellation shader or something. That'd be pretty cool. Let me remember how this works. Type 1 faces, vertex and end vertexes describe a set of vertices of one polygon. Set always contains a loop. Yeah, so it's these mesh verts that actually have the triangles in, I think. So mesh vert is the index of the first mesh vert, and then end mesh verts is the amount of them to draw. And then a mesh vert is basically an element in an index buffer. So yeah, so this is the fun thing that I mentioned kind of at the start of the stream, that going through these BSP files is definitely an exercise in like following in direction. But yeah, what I think we can do then actually is just draw out the whole of the mesh verts buffer. So let's try that. So I don't want faces, I want mesh verts. lookup bytes, mesh verts in file bytes. What do I call that? Mesh vert list. That seems strange. The length of mesh vert list bytes is 105.94, not 106.068. How does that happen? We take length, we drop offset. That seems correct. Definitely showing the right thing. If I pull that, what? How could that not be the case? How big is this thing in total? That seems strange. There aren't even that many bytes left in the file. So, what on earth is going on here then? How am I like 200 bytes out by doing that? Don't seem to be actually reading the whole thing. How could that be the case? It's a bit weird, but Well, if anybody has a clue why I'm missing, so what do I get? I end up seeing that many bytes, yet the file has that many bytes. Nope, sorry, that compared to that, yeah. So I'm like, what, 148 or something like that? I wonder if this look ahead has actually ended up. I guess we can move this up here and see if that was what's causing it. I could look ahead that. Oh, that's got it, hasn't it? That's weird. So yeah, so I forgot to put look ahead on this. Well, I guess it doesn't really matter now. We'll just stick with what we've got. Okay. So we now have 106068, and their entry says there should be 106068 bytes as well. So can we now just stick that into here? No. So there's a couple of things that are wrong. One is that our definition of a vertex needs to be updated. So we were assuming vertices before were just 2 3-element long vectors of floats. That is not the vertex format of a quake-3 vertex. So quake-3 vertex is actually exactly what is in this file, which is, as you see it there, 3 floats for position, 4 floats for text coordinates, 3 floats for a normal, and then 4 bytes for vertex color. Let's write that down. U byte, that's what, just word 8. So there's a bunch of places, so we're going to pay for incurring some, not getting around to doing some refactoring that we were meant to do. If we look at, I think I put to-dos here. Yeah, so our vertex buffer, at least it refers to this vertex. Create vertex buffer. Don't want to have a list of vertexes. Let's just add more coupling and I'll work out how to get to this later. Now we can take a vertex list. I can just use create buffer, which, if I remember rightly, takes device, physical device usage, device. Device usage, a poke function, and a size function. So getting the size is easy. How do we poke that? We basically just want to do it with a mem copy. There is an unsafe interface, but it only works for strict byte strings. Kind of makes sense. Let's actually, oops, bring this up here. There is a memcopy function somewhere in the base libraries. Apparently there isn't. I thought there was. Or is it copy bytes? There we are. Copies the given number of bytes from the second area into the first. So I'm going to be given that. And I've got unsafe, I guess, use a C string. And then we'll just cast it again. That needs to be strict. C string is just a pointer. I think it's that. Need to import those. Hello, IsoVector, just for joining us. Yep, so take out that old definition. copy bytes needs the number of bytes to copy. Yeah, okay. And it's, of course, the very last parameter, so I'm going to undo that. So copy bytes into the first from the source,